Hello everyone. I just wanted to show you a couple more low budget examples of what two-dimensional interactions would look like. This first example is an intersection collision, typical car collision. Somebody heading in one direction, somebody heading in a perpendicular direction. And basically what you need to remember when you look at this type of collision is objects collide at angles perpendicular to each other. In most of the cases here, like you saw in the before picture, and then in the after picture, they tend to stick and move together as one after the collision. So you'll deal with a combined mass in a lot of these cases, moving off at some angle. That's a typical type of intersection collision. Explosions are another type of question. So we've got before. The key with the explosion that you always need to remember, and this seems kind of weird till you start doing a few calculations on this, total momentum before and after is equal to 0. Since this thing was at rest before the explosion, that means there's no momentum. Well, even though all the pieces move off at different angles, their total momentum in the components will add to 0. So whatever's going up, there'll be as much momentum down. Whatever's left, as much momentum to the right. This is how they can use this to find debris on an explosion, or debris when a collision happens, or an airplane collision, or those kinds of things. They basically use momentum calculations to try to figure out where the pieces would be. So in this kind of case, total momentum after of all the little chunks would sum up to 0. And the last type is a glancing collision. So I've got my little pool table here, and when you have a glancing collision, objects are usually colliding at angles other than 90 degrees, and then each object typically moves off in its own separate direction after the collision. So again, you got the cue ball coming in, hitting the other ball at some angle other than 90 degrees, and what will happen is they move off separately at different speeds and different directions. Whatever the type of collision, we're going to treat mathematically the same way. The total momentum in the x direction before and after is conserved. The total momentum in the y direction before and after is conserved. Biggest mistake students make is they just try to conserve momentums. They need to conserve components when you're dealing with the two-dimensional